The Claude CLI now emits commentary progress events during tool execution. When the model produces inter-tool narration like, "I'll read each file and summarize it," the CLI parser captures that text. It emits it as a stream item, kind preamble event. Only the new segment is sent. Assistant text.slice last flushed commentary length.trim. So each narration appears once. Backend text replacements apply before emit, keeping consistency with other rendered output. This producer works with a separate delivery bridge. The bridge forwards item preamble events into the channel progress callback path. Primary CLI runs route commentary through ops.onItemEvent. Follow-up CLI runs use the existing follow-up progress path. Neither channel nor renderer changes are needed. The bridge plugs into existing Telegram and Discord hooks that already handle kind preamble item events. The full path now delivers Claude CLI commentary as live progress. With commentary enabled, OpenClaw emits a preamble item, then tool start, result, then final answer. With commentary disabled, the pre-tool text is classified and suppressed. No preamble appears, only tool start, result, and final answer. Tests confirm the behavior. Text to tool to text to tool sequences emit commentary once, with no duplication or leakage into the final assistant stream. This restores inter-tool commentary visibility in channel progress drafts. Users now see transient progress like, "I'll read each file and summarize it," before tool calls execute. The commentary is transient. It does not persist to the final message. The fix closes issue 87.3.26 for Claude CLI commentary. The fix closes an issue for Claude CLI commentary, and the PR includes real Telegram desktop proof showing live progress rendering during a turn. This release adds 3 key observability improvements for diagnostics, performance, and user experience. First, trusted diagnostics channels now capture tool input and output content. Previously, the capture content.tool inputs and capture content.tool outputs configuration options were documented but inactive. Now, when enabled, the embedded runner emits cloned tool arguments and results over a trusted private diagnostic channel. The OpenTelemetry exporter reads this private data, applies redaction and truncation at 128 kilobytes, and populates OpenClaw.content.toolInput and OpenClaw.content.toolOutput span attributes. Raw tool content never reaches the public diagnostic event bus. Tests confirm the producer and consumer work together correctly. Second, the system now traces the first assistant event for control UI chat interactions. A new first assistant event server timing phase marks when the first assistant payload leaves the gateway fanout. This includes both final flush only and direct gateway injected replies. The control UI captures this timing phase, allowing first message latency to be split between gateway runtime, processing, and browser paint. Tests verify the timing phase emits correctly across gateway and UI components. Third, the system warns when the first assistant reply paint is slow. The control UI now marks slow first assistant timing events with slow true and triggers a visible warning. This applies only to the initial assistant response, not to normal chat timing. A focused regression test confirms the warning fires for slow paint events. Normal chat timing remains buffered only, avoiding noise in routine interactions. This release improves plugin management for ClawHub and the plugin SDK. Installed plugins can now declare and use trusted hooks when explicitly enabled. The plugin manifest can list trusted tool policies and middleware runtimes. Only declared hooks register successfully. Undeclared attempts fail closed. Bundled trusted policies always take priority over installed ones. Duplicate policy IDs are rejected for installed plugins. If a bundled policy later claims an installed plugin's ID, the bundled version wins. A warning logs when an installed policy gets displaced by a bundled one. The Skill Workshop plugin is now retired. Configs with the old Skill Workshop entry no longer crash on startup. Instead, a clear warning appears. The entry is stale and should be removed. The OpenClaw Doctor fix command automatically cleans up the stale entry. This matches the existing behavior for other retired plugins like Google Anti-Gravity Auth. Plugin version drift is now visible in OpenClaw Doctor output. If an official managed plugin lags behind the running gateway, Doctor reports it. The warning shows the installed version, expected gateway version, and a repair command. The fix uses live gateway context, not CLI version, for accurate drift detection. Remote gateway mode skips this probe to avoid misleading local install checks. Exec-backed secret materialization is disabled by default in these probes. Users must pass allow exec to enable secret materialization for diagnostics. This ensures doctor warnings stay safe and actionable without unintended side effects. This release improves memory indexing performance and provider reliability. The OpenAI compatible batch embedding system now groups dirty memory and session files into a single provider job. It submits one source-wide batch job instead of many small ones. Batch polling becomes more resilient with retriable status checks and exponential backoff. The CLI shows source-wide batch repair and source-wide batch submit logs when batching activates. For a workload with 833 memory files and 495 session transcripts, it submits one provider batch job with 1,328 chunks. Inline embedding requests drop to 0. Polling progress reports show increased wait times between status checks, confirming backoff behavior. The local llama.cpp runtime moves into its own provider plugin. Users who rely on local GGUF embeddings no longer lose Node Llama CPP during OpenClaw updates. The plugin owns the native dependency instead of the core package. Existing configurations with memorysearch.provider local continue to work. The gateway starts the provider plugin automatically when local embeddings are configured. Doctor Repair installs the missing OpenClaw Llama CPP provider package if necessary. Memory indexing and search remain in memory core, while the provider plugin handles embedding computation. Agent model catalog discovery now persists cached results to SQLite. The system reads cached catalog rows before expensive provider discovery runs. It writes refresh rows after runtime discovery completes. The cache key includes the agent directory and source fingerprint. A 30-minute TTL governs stale row visibility. Real-world testing shows models list provider moonshot provides expected rows and stores them in the agent model catalogs table. Subsequent runs hit the cache before querying providers. This reduces startup latency and provider API calls for repeated model discovery. QMD JSON search remains one shot per query. Stale REM recall previews get filtered out during recall. The system avoids redundant recall lookups for unchanged content. This keeps search responses fast and accurate. The release introduces a new toggle for QQBot group mentions. Users can now run the /bot group always command to enable or disable the requirement for mentions in group messages. This command works for both the default account and named accounts. When the toggle changes, the runtime configuration cache clears immediately, so the new setting takes effect without restarting the bot. The implementation adds a dedicated /command handler and includes comprehensive unit tests. Before this change, users had to edit config files directly and restart the gateway for mentioned settings to update. The mobile control surfaces for iPad and iPhone received significant improvements. On iPad, the app now uses a sidebar navigation model that mirrors the macOS interface. Destinations like Workboard, Skill Workshop, and Settings appear in the sidebar with dedicated screens. On iPhone, the Control Hub centralizes access to core features with responsive tab switching. The app supports both dark and light modes across devices. Workboard and Skill Workshop now display live gateway status and real-time data. All changes preserve backward compatibility with existing gateway calls and include extensive Swift UI and unit test coverage. The TUI footer now shows the active connection host. When connecting to a gateway via URL, the footer displays host, hostname at the start of the status line. The implementation extracts only the hostname portion and omits credentials, paths, or query strings for security. Non-URL local connections skip this field to avoid misleading labels. The feature is opt-in behind the tui.footer.showRemoteHost config key, which defaults to off. Loopback and embedded local connections remain hidden even when enabled. The change adds formatted logic, tests, and updated documentation. Users can now quickly identify which host they're connected to, especially useful when managing multiple machines over Tailscale. This release improves startup performance across multiple areas. First, the TUI runtime plugins now warm up during history loading instead of waiting for the first user send. This moves the plugin activation work earlier in the startup sequence. The first model request after startup sees a dramatic reduction in delay because the plugins are already ready. Second, plugin auto-enable logic now caches its results within a single event loop turn. When multiple dashboard requests trigger fanout simultaneously, they share the computed plugin list instead of recomputing it for each request. This reduces redundant work during cold start, dashboard loading, and tool catalog initialization. Third, the model catalog build no longer repeatedly rescans plugin metadata when using derived registries. A regression since 2026.5.18 caused every /models call to rescan all plugin manifests. This fix ensures the memoized snapshot lookup works correctly, dropping catalog build time from over 6 seconds to under 300 milliseconds in real-world testing. Fourth, text delta streams now emit the full accumulated message snapshot on each token. Instead of sending the entire assistant message so far with every text chunk, only the incremental delta is included. The agent loop reconstructs the full message from these lightweight deltas. This reduces memory usage and processing overhead for dense local model streams. Finally, startup model metadata is now reused when possible. If the initial chat startup response includes model information, the control UI skips a follow-up RPC call to fetch the same data. This avoids redundant network round trips during initial chat interface rendering.